Hi, my name is Edgar Hoya, and today I'm going to go over Lab 3C. I'm sorry, Lab 3. The objective of this lab is to go ahead and reverse an array with assembly. So, what that entails is to go ahead and obtain the address space of this array, store the values temporarily, and swap the values in that address space. So, first, let's go ahead and show that this code built. So let's go ahead and do a build. Got this thing. Let's save, I guess. Alright, so build project up here on the right side. We don't get any errors. Console, nothing. Build finished. 1909. Well, I'm guessing this is 24/7, so 709 right there. No issues, right? Now let's go ahead and run into the debug. As we can see, whenever we actually build, we should get an AXF file, which we did. This is the file that will be referenced by the debugger. So if I go to debug configuration, the file that we're referencing is lab32, as you can see right here. And I should just be able to hit debug. So let's go ahead and move that connect or start the connection over. All right. So what I'm going to be showing you is the code, the breakpoints in the assembly code, and how these breakpoints affect the registers, which in this case, the main ones that I will be using are my half-word W3s and my full X7, X8, and so on. So these right here. I will also show you what the values are in memory space at that point in time and what it looks like in this assembly. So let's start. First, we should see that we're going to initialize an array. We're going to initialize the end value, and this is going to be parsed over to this print array function, and we should see here on the right side in the console that this array will be printed. So let's do that. So there you go. First breakpoint at 18, and the array was printed. Now this is going to move into this function. So we have a couple of labels: reverse array label, loop label, and exit label. First, we're going to zero out some registers that we're going to end up using. I have some zero temp registers. I have my iteration registers. And in this case, what I'm going to be doing is I'm going to be iterating from the left to the right to basically get the address space of the first pointer and to get the address space of the last pointer, and then so on. So go to the next one, go to the next one, so I can start swapping the address space, right, or the values inside that address space. Then we are also going to store the addresses into X7, X8 registers. So this is for the right and this is for the left. And then I have a couple of temporary register values. X16 and X17 are going to be used to actually do the whole, or to obtain, I guess, the left pointer values. And then we're going to initialize our iterations. So 5 and 6, we're going to initialize at 0, and then we're going to initialize this at 6 minus 1, which is going to be 5. And then we're also going to move our first parameter, x0, into x2 register, so in here. All right, so let's begin that, and let's see what happens once we start, or once we stop there. So now x2 should be referenced, see, to x0, x1, which is our value of 6, which is coming from this n initialized value that's there. We also zeroed out x2, I'm sorry, there's x5 and x6 haven't parsed through the instructions, so this is 0, which is true, and this should be 5, which is true, and x2 should be referenced as x0, cool, and x9, 10, 16, 10 and 16 and 17 should be all zeroed out. So now we're going to move into the loop function. The loop function has a conditional exit. At this point, what we'll be comparing is the values of x6 and x5. So x5 and x6 should come to a point where whenever you subtract them, they would be less than 1. And when that point comes into play, then we should branch out of that function into the exit, which would just return it to the original, I guess, instructions here on the left. All right, so let's move on. Let's break that break pointer and let's press play. All right, so where we have arrived is where we have calculated x7 and x8, which are the address values of the right index. So x7 should now get the address of the should be the address of the index on 56, right? So index on 56 is 5. We have to go ahead and calculate what the hex value of 5 is by doing 5 times 2 to the 2, which gives us x17. At this point, x17 is now 0, and then x16 is going to give us, I'm sorry, yeah, that's what it is. So x16 should give us the right pointer, so it's going to go 14 hexadecimal up. So if we have like, let's see, a calculator here, let's get our initialized array, which is this one. Copy. We should be 0x14, which should be D4, right? So if we actually look at this in this assembly code, let's go to this address space real quick. Show this assembly. So C4 and D4 would be 1, 2, 3, 4, 5, 6. So yes, it did end up getting the right pointer value. So if we look at D4 real quick, what value actually exists in there in memory is 38. So what is 38? 38 is 0x38 is 56, which is the last value of the pointer. So that being showed and on demand, let's go ahead and now store these values into let's go ahead and load these values of x7 and x8 into W3 and W4. So as we can see right now, W3 and W4 are zeroed out, but after we go through this, it should not be zeroed out. So now W3 and W4 now are referenced by 70 and 56. Now we're going to go ahead and swap them in their address space. Okay, so now x8, which was F0, should hold the value of 56. So if we show in memory as 38, right, and as we said, 38 is 56, so there we go. We have now swapped the values in memory. So now we're going to move down, loop through it until we're going to iterate the left and right. So it'll be 0, 5, 1, 4, 2, 3, and then it'll be, and then once that is 3 minus 2 is less than 1, then this should exit the loop, right? Because we only necessarily need 3 iterations. So let's do, this is the end of the first iteration. This is the, and you can keep looking at the values here, W3, W4. And after this loop, it should exit, which it does. So in memory, if we go back to C0, show in memory, oops, let's see, C0 is gone. So let's look at disassembly, and disassembly is gone, I always forget. Regardless, let's actually, I can show you by the target console. So the target console, after this function exit, it continued on. This array was modified, and now it's going to parse that through the array and print it, which is now a reverse function 56, 77, 40, 50, 60, 70, which if you look here is the opposite of that function. And that's it. Thank you for everything. Have a good day.